So let me again share the slides. Okay. So far we have learned what is KCL. Let me go over KVL, Kirchhoff's voltage law. KVL. What that means? That means whenever you have a loop, circular thing, but it must be closed, of course. If you sum up all of the voltages along that one, the sum is always zero. Let me write it here. Sum of all the voltage actually differences. The voltage drops along loop is always zero. Here, if you add up these voltages, it's gonna be zero. If you consider this loop, if you add up all of those, it's gonna be zero. Let me run annotation. And then these two here. Okay. Where is it? Come on. And okay. Here a loop is given. If you sum up the voltage across this resistor, that resistor, and this resistor, it's gonna be zero. If another loop here, you consider another loop here and sum up all of those voltages, still it's gonna be zero. A loop here, a loop here, a loop here, or in this one, a loop can be like this. If you consider that, it's gonna be zero. But in a loop, you need to consider a direction for the loop. Okay? It's again up to you. It can be clockwise or counterclockwise. And at any given point, let's say someone is going to start from this point. Okay? And direction is gonna be clockwise. So that means this guy is gonna add up all of the voltages he sees along this loop. Or here, you may put this guy here, and this guy goes clockwise, counterclockwise. In counterclockwise, this is 15, then the voltage across this one, that one gets back to the first place. So the voltage of those three is going to be zero. Let me solve some examples of that. Let me first turn off this, stop sharing. Okay. Let's say this is a voltage source for 5 volts. For minus 10 volts. And then again, a component. That component can be anything. We have no idea even what is that component. For every component, we need to select a polarity. Sometimes that polarity is given, sometimes not. Let me select this polarity for that unknown component, and this voltage we need to find. Someone may select clockwise, and it starts from this point. So let's write KVL. First of all, this guy sees this voltage difference here. So as this guy sees the negative head first, it's going to be minus whatever this voltage is. Then this guy reaches the second voltage source. But this time, this guy sees the positive head. So it's going to be positive. And how much is the voltage? Minus 10. Then this guy reaches this unknown voltage, but from its positive head. Positive, then unknown V. it's going to be 0. Then, how much is V, you think? Negative 15, then V is going to be 15 volts across this compound. Someone else prefer, let me use blue, to go this way. And instead of starting from that point, that guy starts from this point. So, blue KVL. In the blue KVL, this guy first sees negative head. Minus, and how much is this voltage? Minus 10. Then positive. Positive what? Positive 5. Then minus what voltage? V. So how much is V now? 15 goes to the other side. Negative 15, negative cancel out each other, and it's going to be again 15 volts. You can see these two are equal. This voltage and that voltage. It has nothing to do with the direction of the loop. Okay, so let me go over the slides again. Share content, share. Oh, superposition. What superposition means? It means first of all the circuit must be linear. Unfortunately, all of the circuits we deal with are linear. So that means if you have a couple of sources, different sources in a circuit, let's say this is one source here and there is another source here. We need to find the current passing through this resistor. If we can turn off some of, it's up to you. How many? If you have 10 of these voltage sources, you could turn off 3 of them. Then you can go over the next 2, and then you can go over the next 5. Okay, it's up to you to turn off some of them. Here, let's say turning off this one, and then the circuit is gonna be like this. All of this current then goes through that short circuit, and then in the other one, someone is gonna turn off the current source, and this is going to be a current passing through that one. If you are interested in this current, that current is the sum of this and this. Okay, it has its own application in actually in electronics. In electronics, usually you bias a circuit. That means you start the circuit. Let's say you have a microphone. Okay, that microphone gets connected through a coupling capacitor to a simple transistor, BJT transistor like this. And here you have a speaker connected to the source, and this one is connected to the source, VCC, VCC. That's the name usually people use. If you have a look at this circuit, without having this one, just this is kind of a source, okay? When someone speaks here, that vibrations generate a small voltage, and that small voltage passes through that capacitor, reaches through this one, and this one amplifies that. In order to analyze this kind of circuits, people first turn off this part, this source. Using the sources connected to the circuit, they analyze the circuit. They find the voltage at this point, that point, the currents passing through the components and everything. And then after, they can turn off this voltage, the source, okay, and just focus on this one. And whatever goes through this one is the sum of those two, the effect of the sum of the effect of those two sources, okay, in this one. This is called superposition. You will see applications of that in electronics one a lot. And if you have a look at this symbols here, it's just for a short review. A voltage source is going to be short circuit and current source is going to be open circuit. Let me go over another slide. Let me see how long is that. 10 minutes. Let me record another video.